closed line integral of dl, closed line integral of dl along the path along a circle of radius is 4 meters. They ask you to find the closed line integral of dl. So here this they ask you to find the closed line integral of dl. Here what we have, this is dl, this is 1 into dl. I can say 1 is a vector scalar quantity. So for scalar quantity, can I apply Stokes theorem? The Stokes theorem, divergence theorems are valid only for what? Vectors only. So here it is a 1 is a scalar, so we cannot apply the Stokes theorem in this case. Then what we will do here, see this thing. So they asked to find closed line integral of dl. So that means, consider I have a circle of radius is something r. Now this is my x-axis and this is my y-axis. Now can I call this circle is a cylinder? Can I call the circle is a cylinder, isn't it? For cylinder we have like this now. This is the cylinder. What are the parameters in the cylindrical system? Rho, phi, z. As height equal to 0, then what I can say? As z tends to 0, the cylinder will become a circle. Isn't it? So I can say this cylindrical system having these elements. What I can say now, the circle, I can say rho comma phi comma 0. I can say. Now I want to do the integration of the dl, the small strip, in a complete circle now. So I can take a small strip here, and this radius, this is the small strip now here, having a radius is rho, and this angle is phi, I can say. And the small strip we have taken here, I can move strip here, here. We can move along the circle. We should move or not? So I need dl. dl means here, if I change the strip now, you tell me which is variable, which is constant. Is there any change of rho value? Rho value constant at every point, rho value constant, but phi value changes or not? So what I can say, change in length along phi direction is called as rho d phi. Change in length along phi direction is what? Rho d phi. So what I can say, it is the phi limits are what? 0 to 2 pi in a complete circle we are doing now here. When the point is here, the phi is equal to 0. And if I do the rotation of complete rotation, phi limits are 0 to 2 pi. And change in length along phi direction is what? Rho d phi. So I will do this integration now. Rho is a constant. Integration of d phi is a 2 pi minus 0. So I can say 2 pi rho. That is nothing but what now here? We observe carefully. Rho is nothing but radius we have taken now. That is nothing but one circumference of a circle only, isn't it? So how much this value I can say now here? That is 2 pi into 4. So what's the answer is 8 pi. Next problem. The value of the integral, line integral of dl along the curve C, which is the curve C. They given the curve C, which is given as like this. And they given the curve as like this. This is the path they give it, but this path we need to get it. Integral of dl along this thing here. What we should do here? Now here also this will be also seems to be like a circular shape, some part we have now. Now here also we can write so we'll split this as 3 parts. Now let us say first one path is the second path and this is the third path now. So I can split here from here in this path. Now what is the variable I can say now here? Rho e changes, no changes, phi e changes or not. So for first path, so this is the first path for dl, which I can write it as what now here? So radius is given as something capital R. Radius is given as capital R, and change in length, what I can say here, that is R into d phi now. Tell me phi limits are what I can say, 0 to pi by 2. So how much it is I can say now here. And so in the problem they has given the directions also. Let us consider the directions also, variations also we are considering. Directions also I will indicate. And this I can say it is an EFI direction now. So how much this value we can get, tell me now here. That is R into pi by 2 into EFI now. Now for the second path, tell me second path now, what the variable here, and here to here we are moving, this is second path now, and you tell me which is variable here, and this is a positive y and this is a negative y now here. This is plus R and here this is minus R. I can say y value changes now here. That means here we should use a Cartesian system. So I can write it as into dy so this is second path dl, which I can write it as what now here. So this is dy into ay direction. Limits is what here, r2 minus r. So from this get this thing here, integral of dy is a y limits. So what I can write is minus 2r into ay now. But this is for second path. Next, what about third path here? And third path here now. Here the phi value 0. Here the phi value is pi by 2. Here the phi value is how much? Pi. Here the phi value how much it is? 3 pi by 2 now. Now here the path is like this in this path. So this is the third path integral of dl, which I can write it as what we can say, this is integral of from where to where, which is the variable here, phi value changes now here. So I can say this is 3 pi by 2 to pi and r into d phi into a phi I can say. So from this what I can say, this is now r into, so this is what it is, a pi minus 3 pi by 2 into a phi na. So this is minus r into pi by 2 into a phi. This is for third path. This is for third path. Now so here, so sum of all is this final answer or not? So that means what we can say, this is the integral of dl, which is equal to what now? So this thing and this thing will get cancelled, and so only this is only left out now here. So how much I can say, this is now, this is 2 minus 2r into ay cap minus 2r into ay cap. Next problem. The region specified by this thing is given rho phi z has a volume of, how much is volume in this case now? What the system is a cylindrical system. Cylindrical system, what the elements we have? Cylindrical system, rho phi z now. So volume is we need all three parameters. Now what is the change in length along rho direction? Change in length along rho direction is d rho, along phi direction is rho d phi, along z direction is dz. So what is the dv? I can say now here rho d rho d phi into dz I can say now. So from this, how I can get this volume now here? This volume, which is given as what? Volume integration of dv. So this is given as volume integral of dv is what? Rho d rho d phi and dz. So which is equal to, I can split the limits now here. Rho limits are what? 3 to 5 rho into d rho, and the phi limits are what? Pi by 8 to pi by 4, so into d phi, and z limits are 3 to 4.5 into dz now. Simplifying, this is rho square by 2 limits 3 to 5, sorry, into pi by 4 minus pi by 8 and 4.5 minus 3 means 1.5, and do simplify and get this answer. What will get it is 1 by 2 into this is 25 minus 9 now, and this value pi by 8 now, and this is 3 by 2, and do simplify. Finally we can get 25 minus 9, 16, yes, 16 into 3 pi, yes, by what it is a 8 into 4, yes, doing simplification, 8 2's now, 2 2, so how much it is now here? 3 pi by 2, get this value. So it is 3 into what is a pi value? 3.14 by 2. Do simplify and get this value. Next problem. Consider a closed surface S surrounding a volume V. If R is a position vector, then n cap is a unit normal, then the value of closed surface integral of 5r dot n cap into ds. So here they ask you to find this closed surface integral of 5r bar dot n cap into ds now, which is equal to what I can say. I can take out 5 is outside, 5 into closed surface integral of what? R bar dot n cap into ds now. So what is this? N cap is a unit normal vector, and so by combining this thing we can write it as 5 into closed surface integral of what I can say here, basically ds. Well, ds is a surface area. Surface area is a vector or scalar? Vector quantity, so it should have a magnitude as well as a direction also. So the magnitude of ds bar, yes, Ravin, yes, welcome. Magnitude of ds bar, ds we can say this thing as a ds vector, and what's the direction of the ds is a surface area. What's the direction of surface area is always what direction? Normal direction. So to indicate the normal we use n cap. So now I will combine this thing here with, yes, outward normal, correct. So this will combine this thing as what I can say, this is r bar dot ds bar I can say now. So here you can see here, now I have a closed surface integral of a vector dot ds. Now can I apply the divergence theorem? Can I apply the divergence theorem now? Tell me divergence theorem. By using divergence theorem, what we can do? We will convert the closed surface integral to a volume integration. So tell me this thing here, 5 into what I can say, volume integral of what? Del dot r bar into dv na. So we need to find the del dot r. So find the del dot r now. Divergence of this r now. What is r? Is a position vector. Yes, correct, Praveen. So this r is a position vector which is given as r bar is given as xi plus yj plus zk position vector now, and this divergence is what? 3. So this divergence value will replace here. Then this is 5 into volume integral of 3 into dv now. Then this I can say as 15 into volume integral of dv I can say as v na. They given having this volume this much v. So what's the answer now? It is a 15v. So from this what's the option now here? So from this what's the option now here? Option D. Now shall we move to the next problem now and see this thing. So a vector field V is given as D is equal to 2 rho square A rho plus Z AZ in a cylindrical system, and they ask you to find closed surface integral of D dot ds. I think this is the problem given gate 16. So they has given D. So as usual, so the closed surface integral of D dot ds, we can apply the divergence theorem. So it is volume integration of what? Del dot d into dv na. So first we need to find a divergence. Divergence in what system is a cylindrical system. Cylindrical system divergence we need to use now here, and cylindrical system divergence theorem, divergence expression which is given as what it is a del dot d bar now, which is given as 1 by rho dou by dou rho into what? Rho into d rho. Yes, the first term. Next 1 by rho into dou d phi by dou phi and dou d z by dou z I can say now. Yes, and d value, how much the d value is a 2 rho a rho, or the d is a 2 rho into a rho cap plus what? 2 rho square plus what? ZAZ. Yes, ZAZ. So here this is my d rho na, and this is dz. D phi value 0, and find the del dot d now here. Del dot d which is equal to 1 by rho into d by d rho dou by dou rho of rho into a rho. So it will become 2 rho cube na, and this term 0 and this term is 1. So how much it is? Yes, 6 rho plus 1, correct? So this is my del dot d we got. Now what we should do here, this del dot d had to use here now, replace here to get these expressions. So from this what we can say now here, so this is the closed surface integral of d dot ds, which is equal to volume integral of del dot d. We got it as what? 6 rho plus 1 into dv now. Tell me dv now here. What I can say dv now? What system? Rho phi z. And cylindrical system now here. For dv means how many elements are required? 1, 2, 3. 3 elements are required or not? So we need to take see all 3 elements. Change in length along rho is a d rho. Along phi is a rho d phi. Along z is a dz. So in the coordinate systems I ask you to remember this analysis. Right. Hope you all of you know this thing. So now dv means all the 3 elements are required now. So what we can say, it is a rho, d rho and d phi and dz. So we'll split this integrations. Volume integral of this is 6 rho square, and we'll directly split the limits now here. Yes, rho limits are 0 to 1. Phi z is from 0 to 5. Yes, so this is rho limits are 0 to 1 and phi limits, circle now here, complete cylinder means 0 to 2 pi, and phi z limits, sorry, and the z limits are what? 0 to 5. And we can split this thing as, yes, and we'll do this integrations now here. So what we'll get now, this is 6 rho square d rho d phi dz, and plus same limits now. Rho limits are 0 to 1, phi limits are 0 to 2 pi, and z limits are 0 to 5. This is rho d phi dz, and do simplify, get this answer. How much you will get this answer now here? 40 pi. Final answer is it 40 pi, isn't it? Final answer, Praveen. Yes, right. Right, like this we need to do. So final answer is how much it is? 40 pi. Right, like this we need to approach now. Now see this problem now here. Here also this problem. Here there should be close bubbly also there. Unit Q with one corner at the origin and the edges are parallel to the coordinate axis. Yes. Now here also what we can do here, divergence theorem, the closed surface integral of v bar dot ds I can say now by combining the n cap with the ds bar. Ds bar directly you can write now, and that will be divergence theorem, volume integration of del dot v into dv, and so find del dot v. Divergence we should find now. Tell me divergence here, del dot v, and here this is the vx now, x derivative, that is cos square y. This is vy, y derivative 0, plus this is z derivative, this is, we'll get sin square y now. So how much it is? 1. So from this what I can say, this is volume integral of 1 into dv. So this I can write it as what now? Simple volume now. volume of what? Cube, now unit cube. But the volume of unit cube is, I can say a cube, where a is equal to side is 1 now. So the answer is 1. Right, fine. Let us do this thing fatafat. Consider the function f is given as 1 by r square into ar cap, where r is a distance from the origin and r cap is a unit vector in a radial direction. Then they ask you to find the divergence of the function over a sphere of radius capital R, which includes the origin is. Yes. So I think this problem also given gets 16, I think so. 16, yes. For electrical it was given. And this problem is also a mass problem. See what we can do. Divergence of this function over a sphere of radius. Yes, answer 0. Yes, answer 0. Yes. And Praveen, what you do is, and go to the you after completion of the class, go to the IIT's website and see the GATE 2016 paper of electrical. 16 electrical paper, and see the given thing, see the paper and question number with the question, and see the key given by the IITs. Key given by the IIT after the class. The answer is not 0. The answer is 4 pi. Yes. Yes, I will tell you how to approach this thing, and you just cross check here. And most of the all the institute has given this has a 0 answer, that 0 is a wrong answer. Almost all the top institutes, I don't want to mention the names, and go for this thing here, that is a 4 pi. Will tell you how to proceed this thing, what is the actual thing here. Right, now see this thing here. Here they ask you to find what they ask you to find. Divergence of the given function means what? Divergence, the divergence of the given function. Yeah, you will understand, just wait. Just listen and you will understand. Divergence of a given function over a sphere of radius. So that means what now here? The sphere is a closed surface or open surface? Closed surface now. That means volume integration of dV. This thing they ask you to find. This thing they ask you to find the meaning of this thing. So most of the fellows will used to confuse this thing. Yes, you are correct. So the divergence of the function over the sphere of radius. You can say previously what we did, and cube at the center we are finding the previously closed surface. What we did volume integration we did now. Similarly, so over one sphere of radius of some surface means we should do this volume integrations. We should do this thing, we need to get it. This thing we need to get. Now what we can do is, first of all, what is F is the F is given as what it is, a 1 by r square into, I can say this is ER cap. What is R bar here? What is R bar? Is a unit vector now, which is given as what now? Xi plus yj plus zk. Xi plus yj plus zk. So what is the modulus of R bar is square root of x square plus y square plus z square. Now what this is given as 1 by r square means what it is, a modulus of square now. This is x square plus y square plus z square, and this x square plus y square plus z square which is nothing but what I can say, this is a nothing but radius of the sphere only. Radius of the sphere, na equation of a sphere. So this x square plus y square plus z square, then I can call this as what now here, x square plus y square plus z square. This I can call it as a capital R square. So from this, the given function f bar, which is what the f bar is, a 1 by r square. Yes, this I can write it as 1 by capital R square, can I? And this ER cap. Next, what we have, this is ER cap, na unit vector. The unit vector is given as vector by its magnitude, na this by magnitude. So what I can write now, it is a xi plus yj plus zk. Yes, by what? Modulus of r means I can say this as a r. Isn't it? So finally the given vector f, which is given as 1 by r cube into what it is, a xi plus yj plus zk, na? This is the given function. Understood up to here? Now what we should do here? Now what we should do, what they ask me to find here? Now divergence. Yes, now tell me divergence now here. Divergence of this f is what now here, 1 by r cube into 3, now this divergence. Now next what we should do here, this volume integration we should do. Now tell me, volume integration of what? Divergence of f into dv, which is equal to what now here, volume integration of 3 by r cube into dv now. So which is equal to 3 by r cube is a constant. Tell me now here, integral of dv is a volume of the sphere now. How much it is? 4 by 3 pi r cube. Tell me what will get now? What will get now? So this answer is how much it is? 4 pi. The answer is how much it is? 4 pi. Praveen, understood? Right. One other beautiful problem. Right, like this we need to see. Now we'll move to the next problem. Next we'll do fastly, yes. The gradient is defined for what? Gradient is defined for vector scalar. Gradient is defined for vector scalar both. Only scalar. Gradient is defined only for the scalar. Divergence is defined for what? Vector. Curl is defined for the vector. Right. And the divergence of the vector field they ask you to find. They given some function, they ask you to find the divergence of the vector function. Yes, fine here. So tell me this thing here, del dot v. Here the very confusing thing here. Why? Because they given inside cos xy. We should be very careful here. Now tell me divergence now here. dou Vx by dou x. Now here we should apply the u into v rule. Now here tell me this thing here. So this is minus is there now, minus of what now here, u into v. So this is x into cos x, derivative is minus sin xy into y now, into y. Y is a constant, x derivative. Next again plus what, cos xy, isn't it? And this derivative 0. Next plus again u into v rule only. So it is y into minus sin xy into x. Yes, plus cos xy, correct, plus z derivative. This whole term is inside the bracket now here. So this is what now here, this is like this. So sin cos of what, no here this is only the bracket, this is only the bracket. So this is cos z square into 2z. Yes, check it. Correct only now. So plus, see this thing, see the cancellation now here. Yes, and this term will get cancelled, this term will get cancelled. So finally only this will be left out now. Yes, fine. Next problem. The divergence of a three-dimensional right vector. What a simple problem. Next, find the divergence of the field. They ask me to find divergence in what system? Cylindrical system. Fatafat, divergence लिखो. Divergence of P we need to get now. That is 1 by rho. That is 1 by rho into what? First term will be modified now. Dou by dou rho of what? Rho. That is rho square into sin phi plus 1 by rho into dou by dou phi of rho square z plus this derivative directly we can say cos phi. Yes, and here this term is 0 now, and here what we'll get it is 1 by rho into 2 rho sin phi plus cos phi. So finally del dot p, which is equal to 2 sin phi plus cos phi. So what's option B? Next, del dot f, which of the following is correct? Again the same analysis. Now do it fast. Del dot f, which is equal to 1 by rho into dou by dou rho of, this is rho square plus this is 1 by rho into this derivative, rho into sin square phi derivative sin 2 phi minus 1. So how much it is? 2. So this is finally what will get it is 1 plus sin 2 phi. Check it. What happened? What happened, Praveen? Praveen, is it okay now? What if struck? Yes, is it okay, Praveen? Get this thing here. So find out this value del dot f. A system problem, or you have a doubt in this problem? Any doubt in this problem? Is it okay now? Fine. Is it fine now? Continue and do this problem. So this is my del dot f now. So find the del dot f at a given point. So we'll find the del dot f at a given point now. Find out. Yes, so this del dot f when phi is equal to pi by 4. How much it is? That is 1 plus 1 now. This is 2. And del dot f at phi is equal to 0. How much it is? 1 now. And which will be satisfied? This is 2 times of this value now. So option D. The next problem. Find del cross A at the origin. Del cross A at the origin. Fatafat, do it now here. Del cross A. So which is equal to ax, ay, az now. Next, dou by dou x, dou by dou y, dou by dou z. And this is y into cos ax 0. This is y plus e power x now. Now expand this curve now here. Ax cap into closing this round column. This is what I will get, it is 1 minus 0 minus ay into what now here? This is e power x minus 0 plus az into what? 0. This is 0 minus cos dx. So this is curl now here. They ask you to find at this origin. Origin means the replace the point as 0 0 0. Then so finally what I can get now here, del cross A, which is you'll get it as ax minus ay minus ay, and then minus az, isn't it? So what's the option here? A. Praveen, got it? Next problem. If the electric E is given and H is given, they ask him to find E cross H. So no need to find what is E, no need to know what is E, what is H. Simply find E cross H only na. We just want to find E cross H. So find out this thing here. Ax, Ay, Az. So this is minus 2, 3, 5, 1, 3, minus 4. So simplify this thing here. Ax into what I will get now here? Minus 12 minus 15 minus ay into what it is, 8 minus 5 plus az into what it is, minus 6 minus 3. Check it now here. Minus 27 plus how much it is, ay. This is 8 minus 5 and this is 9. So it is 3 only na. Option A. Praveen, isn't it? Yes. Next to the next one here. Unit vector, they ask about curl A. Del cross A. Yes, what del cross A now here? Same thing now here. Ax, Ay, Az. So this is dou by dou x, dou by dou y, dou by dou z. This is cos x sin y. This is sin x cos y 0. So this is Vx cap into, so what will get, 0 minus 0 na, minus ay into what, 0 minus 0 plus az into what now here, cos x cos x into cos y minus yes, so this is az. So it is what we'll get now here, cos x into cos y minus sin x into cos y. Check it. No, what will get is a cos x into cos y minus, so what's the answer, 0. The net value 0 na. Yes, correct. And next problem, do this thing here.